Okay. So today we are going to see the classification algorithms in brief, because it is not possible to go in the depth of every algorithm in just 1 hour. Okay. So let's start with importing the important libraries. Okay. So as you can see, NumPy, Pandas, Matplotlib. Okay. These are the main libraries. Okay. I think Pandas is repeated. Along with that, we need sklearn. sklearn is one of the most important library for like for applying the model for model selection, pre-processing, matrix, and linear model. Okay, so these are the things we need from sklearn library. Okay, for what? So model selection we are using for train test split. You will get to know the significance of each library one by one. Okay. So the next is, after initializing all the libraries that we need in our algorithms, now we have to import our data set. Okay. Yes. With the help of Pandas library, and split our data set into the training and testing set with the help of the train test split library. Okay. So let me share one screen with you so that I can explain it. Text file. Yes. So as I said previously as well. Yes. Where is the test? Yes. Okay. So train and test. So your first thing is your data. Okay. So you have to divide your data in the two parts, train and test. Means for you have to give some data, means you have to separate your data where you have to put half of data in test, half of data in test. Okay. So it is not exactly half, the ratio is 80-20. We can also take the ratio of 70-30. Okay. Because more data you use for your training purpose, more accuracy you will get at the output. Okay. Sorry. So this is all about the train test data, and that split. Okay. So the split part is there. Yes, the train test split. Yes. So the train test split will split your data, means your complete data, into this part, 80-20. Okay. So here we are using pandas to read our library, and in X, okay, actually these are the columns of your data set. So let's see how the data set looks like. Okay, so just let me check if I have saved the data. Okay, so is my screen is visible? Okay, not exactly. Okay. So is this Excel sheet is visible?
Yes, ma'am.
Okay. Okay, so this is your data with user ID, with gender, with age, and this is your estimated salary. Yes, this is your estimated salary. And the last is what? Purchased. So it is, you can assume that your data is, so let's see, yes. So here you can see that first means first initial columns, that is user ID, gender, age. Okay, it belongs to the X. Okay, X variable, and the last column, which is fourth column, estimated salary, is belongs to Y. Okay, that is what we have to predict. So the thing is, we are going to predict according to age the salary of that particular person. Okay. So here by using this line X train, X test, Y train, Y test, we are splitting our data. Train test split, and test size is 0.2. That means, as I told you, it may be 80-20. So 80 goes to your train data and 20 goes to your test data. Okay. And if you have any doubt regarding this parameter, there is one site. Okay, sklearn. Let me show you. sklearn.org. Okay. On that site, you will get everything. Okay, so let me show you the site. Yes. Is my screen visible? This scikit-learn.
Yes, ma'am.
This site is, means here you will get everything, every line of code, what it means, what it not means, every parameter. Okay. So means not in this only code. If in any code you have any problem, you can check this sklearn.org site. Okay. And if you have any error in the data, you can check for the Stack Overflow. That Stack Overflow will give you the solution for every error. Okay. So the next part is, sorry, as we divide our data set on the basis of train and test sets, now we have to scale our feature data set with the help of standard scalars library and apply logistic regression on the training set and check the accuracy score with the help of accuracy score library. Okay. So the next thing is this is called as feature scaling. Okay. This is one of the most important part, or one of the most important parameter. Okay. We are using like standard scalar. In the next session, I will try to take a special lecture on the parameters. Means the parameters like this. Okay. So S is the standard scalar extend, sc.fit transform extend. Here we are just scaling it. Means all the all the train data and test data, we are making sure. Okay. Means we are like applying logistic regression on that. In the previous lecture, we also saw one logistic regression, like, right? In that lecture, we saw that how we performing log, if you remember. Sorry. So the next part is what is logistic regression. Okay. And how, means what is exactly do. Okay. So you can see logistic regression uses sigmoid function above to return the probability of a label. So if your people are aware of sigmoid function, does this look like this? Is it so? Anyone know how sigmoid function looks like? Okay, so this is your sigmoid function, or else I'll show you the image. Gently sigmoid function. I'm sorry. So yes. So can you see the sigmoid function? This is your sigmoid function. Okay, means in it is comes in classification. Okay, this is also linear. That means this is regression. But logistic regression comes under the classification model because it helps you to give the output in the two classes. Like if you put any threshold value here, means we can take any threshold, we can put it. So if you assume this as a threshold, which is I think 0.6. Okay, so we can directly say that the value below 0.6 are belongs to class A, and value above the 0.6 are belongs to class B. So here just by using threshold, you can convert this linear regression into logistic. Means this is example of logistic regression. Okay, so it is also it belongs to classification. This is how it belongs to classification. So this is the theory belongs to sigmoid function. It is widely used when classification problems is binary. As I showed, true false means upside, either you can say it is true or false, win or loss, positive negative, right? Or yes, or 0 or 1, as we already discussed in logistic regression in the last Friday Saturday. The sigmoid function generates the probability output. By comparing the probability with the predefined threshold, the object is assigned to a label accordingly. As I said, you can predefine your threshold value. Here we just assume 0.6 as a threshold value. Okay. So let me show you this again. Okay. So if you can see here, as we have here one threshold. Okay. So can you see that how we assign the label? Okay, the next is fitting logistic regression to the training set. So this is the main formula where you are using this logistic regression model on your data. So classifier, this is the name of classifier, logistic regression. So every time you will go for the next, like neo base, k nearest neighbor, logistic decision tree, random forest, anything. So this formula will change. Means here it is logistic regression. Okay, with random state equals to 0 and classifier dot fit x train y train. This line is using your this logistic regression. Okay, so if we see the output, so for output we have to make all the screen markdown, and we will just run the code. So this is also your markdown. This is your code. Okay, this is also markdown part, and this is your code you have to run. This is also your markdown. Okay, and this is your code. This is again your code. Here we are predicting and checking the accuracy. So if you see here, the accuracy score is 0.92. Okay, for the Y test and Y predict. Here we have applied our classifier, okay, logistic regression classifier on the training set. And here we are predicting our output on test set. That's why we get the accuracy score 0.925. Okay. So anyone is saying in chat?
Please, ma'am.
Okay. No, someone is, I thought someone is texting in chat. Okay, fine. So this is your accuracy score for logistic regression. So the next classifier is decision tree. So decision tree builds tree branches in the hierarchy approach, and each branch can be considered as a if-else statement. The branches develop by partitioning the dataset into the subset based on most important features. Okay, final classification happens at the leaves of the decision tree. So let me show you how the decision tree graph look or image looks like. Okay, so decision tree, yes. This is your decision tree. Okay. So if you see here, the process start. This is the example of like you want to accept the offer or not. So this is called leaf. Okay. This is your next branch. This is your next branch. And this is your leaf for the tree. This is also leaf. Yes. So here, as you can see, if sorry. So the salary is, this is the your salary range. Okay. So the thing is, you want to accept the like offer or not. If you want to accept, then if you want to reject, then you can directly decline. Okay. So if you want to accept, then what parameter you will see? Is that office is near to your home? If it is yes, then go. If it is no, then you can just decline it. If is that office provides fast facility? If yes, you can accept the offer. If no, you can decline. So this is how your decision tree works. Means it is depends on branches. It will create branch and branch and branch, and the last output depends on your leaf node. This is your leaf node. Okay, this is also your leaf node. Okay, so as I said, you just need, here you can see the classifier is your logistic regression. Okay, guys, and one thing I just want to clear, before applying this, you have to perform all the EDA we took in the previous session on your data. Okay, you have to complete extract the features from your data, everything you have to do previously, and then you can start with this model. Okay, you can't use this data, this model directly on your data, because first thing is you have to perform the EDA on your data. So here, like decision tree classifier, we are using this DTC.fit, and then if you check the accuracy, I'm making this markdown and I'm making this code. Okay, where is it? No, for that I need to make this markdown. I need to make this markdown. Then only I can go for the code. Now, if I run the decision tree, so you can see the accuracy came is 0.9. Okay. So the next part is random forest. Okay, so accuracy varies as per your classifier. You can check all the classifier on one data set so that you can see which classifier gives you more accuracy. Okay, so the next is random forest. So as the name suggests, this is your decision tree. It is of one tree, and random forest is a bunch of trees. As the name suggests, it is a forest. Okay. So random forest is a collection of decision tree. It is a common type of ensemble method which aggregates result from multiple predictors. So in decision tree, we are using the output of one decision. Here it uses the output of many trees. Okay. And then what it do, like see, random sampling of original data set, and it takes the majority of vote from the trees. Okay, compared to decision tree, it has a better generalization. So in the decision tree, we will get a single output. In random forest, we will check that our means check for a many decision tree, and then we will decide depend on its vote. Okay, so let me show you how random forest look like. So this is the simply random forest. As I said, this is your first decision tree model. This is your second decision tree model. This is your third decision tree model. Okay. So it takes, means if your first decision tree is assuming, means giving the output of class A, it is giving the output for class B, and third is also giving the output for class B. So the your output will become class B because majority is of class B. Okay, so it depends. It is works on the majority voting. Okay. So the next is, okay, guys. If in 2 minutes meeting will end, please join again. Okay. So as I said again, you just have a one line code for a model. You just change that line of code and you will get, okay, you will get the new code for the random forest. So if you check the accuracy for this, it is showing 0.93. So as you saw for the decision tree, it was 0.9. And for decision tree, random forest, it is of 0.93. Okay, it is more accurate than decision tree. So the next one is support vector machine. So support vector machine finds the best way to classify the data based on the position in the relation to a border between the positive class and a negative class. This border is known as the hyperplane, which maximizes the distance between the data points from different classes. Similar to the decision tree and random forest, support vector machine can be used in both classification and regression. Okay, this comes under linear model. Okay, so I also have an image for this SVM. Okay, so this is how the your support vector looks like. Okay, so this is your main margin. Okay, this is your positive hyperplane. This is your negative. Yes, this is your positive and this is your negative hyperplane. Okay, so if this line, okay, it all takes the decision on this hyperplane, based on this hyperplane. Okay, so this is your support vector, means if this point lies in near to the negative hyperplane, then this belongs to your one class, and if the points lies near to the positive hyperplane, then it is your another class. Okay, and you can decide the margin for this. You can extend this or you can decrease this as well. Okay, these all comes under the parameters. Okay, so for